Hello everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to study ICSE Class 10 Maths Chapter 19 Construction. We will be solving questions from exercise 19. Ready? Let's start. First, we need to know a few basic things before going deep into this chapter. How to draw perpendicular bisectors of a line segment. What is a line segment? So, here I have drawn two lines. Which is a line segment and which is a line? Okay. Here, this means the line is extending to infinity. Okay. And here, we have boundaries. From here to here. Okay. So, this is a line that is something that is extending on both sides to infinity. We don't have any limits. When limit comes, it becomes a line segment. Okay. Now, we are going to draw perpendicular bisectors. Perpendicular means there should be an angle 90 degree. Bisector means divides into half. The word bisection means dividing into half. For this line, how to draw perpendicular bisector is what first we are going to discuss. Okay. Now, let us take a line segment AB. To draw perpendicular bisectors, it is very simple. You need a ruler, a compass and a pencil. Okay. First thing to do is take the compass and keeping the compass at this point A as center and with any radius. That is, it is not necessary that we have to take a fixed value to draw a perpendicular bisector. Okay. Now, if AB, let us take AB is 10 centimeter. If AB is 10 centimeter, you have to take a radius such that the measure is greater than 5 centimeter. Okay. The radius which we take is greater than 5 centimeter. That is half of AB. If AB is 10 centimeter, half of AB is 5 centimeter. We have to take any measure that is greater than 5 centimeter. We can take 6, 7, anything. Okay. So, taking some 6 centimeter, we have to take A as the center and 6 centimeters radius, you have to cut an arc. Okay. Similarly, now B as center and the same measure, remember the same measure, we have to cut another arc. Okay. So, this is the top portion. Same measure taken at the bottom portion, keeping A as center and the same radius, cut another arc here. Now, B as center at the bottom, cut another arc. Okay. Now, join these two. Okay. The intersection of arcs, we got 2 points. Join these 2 points. Okay. This is the required line. Okay. This is the line which bisects AB. Okay. Here, when you measure this angle will be equal to 90 degree and AB is divided into 2 equal halves. Say this point is C. We'll get AC equal to BC. And this angle is 90 degrees. So, this is how you can draw a perpendicular bisectors. What we have done, keeping A and B as centers, taking some measure, we are drawing arcs at the top and bottom. The arcs from A and B drawn meets at 2 points. When intersection of these arcs, we join with the line, we get the required line which is the perpendicular bisector. Clear? Okay. Let us discuss the construction of some basic angles we have studied in previous classes. Here, if you need to construct 60 degree, how to construct 60 degree? It's very easy. Draw a line segment AB. Okay. Now, take any measure in your compass, keeping A as center, draw an arc. Okay. Here you got a point. At this point, the arc intersects the line AB. Okay. The arc cuts line AB at this point. Now, keeping this point as center, we'll draw another arc, remember that this measure should be same. You have taken a measure in the compass, you should not change the measure. Keeping the same measure, you will cut another arc here. Okay. Now, when you join this A and this intersecting point, intersection of the arcs, you get a straight line like this. When you measure this angle will be 60 degree. This is how you will be drawing 60 degree. Very easy, right? So, related to 60 degree, we are going to construct some other angles. Here you got 60 degree. Now, to get 120 degree, what can be done? What is 120 degree? 2 times 60 degree is 120 degree. First, we will draw 60 degree. Okay. How to draw 60 degree? Line segment AB. Draw an arc of some measure with A as center. With the same measure, keeping center here, cut an arc. You will be getting 60 degree. Okay. To get 120 degree, just very easy. Now keep the center, the compass here at this point. Okay. And cut another arc with the same measure. Never change the measure in the compass taken. Cut another arc. Okay. If you cut at this arc and join A and this point, you will be getting angle 120 degree. So, we got 60 degree and 120 degree. Now, if you need to get the angle 180 degree, 180 is 3 times 60 degree. To get 180 degree, it's very easy. We don't need to do all these steps because 180 degree, you will be getting a straight line. Okay. So, I'll just show you. AB is the line segment. We draw an arc with some measure and A as center. Cut the first arc with the same measure. You got 60 degree. Second arc, you got 120 degree. And the third arc, when you cut, you will be getting the angle 180 degrees. Okay. This is how you can construct 180 degree angle. Okay. Join the point and A. This measure is 180 degrees. So, we got 60, 120 and 180 degrees. Now, what about 90 degrees? If you are asked to construct 90 degree angle. How to construct 90 degree angle? Let's see. Everywhere you need 60 degree. So, first step is constructing 60 degree. Okay. This is a straight line segment. AB. Draw an arc. Okay. We have taken some measure and A as center. Draw an arc. So, this is a required arc with the same measure and center at this point. Cut an arc. We got 60 degree. Cut the second arc here. So, we got 120 degree. We know that 90 degree, 120 degree is greater than 90 degree, greater than 60 degree. Okay, which means 90 degree lies between 120 degree and 60 degree. 60 degree plus 30 degree is 90 degree. 120 degree minus 30 degree is 90 degree. Okay, here what we are going to do is, with these 2 points, we are going to keep these 2 points as center. We are going to bisect this angle. Okay, here we have 60 degree. This measure is also 60 degree. When you bisect 60 degree angle, we get 30 degree each. Okay, so 60 degree plus 30 degree will give us 90 degree. We need to bisect the angle which is formed here. Okay, for that, keeping center here, draw an arc. Keeping center here, draw the second arc. We got a point where the 2 arcs intersects. Now join this point and A. What is the measure? This measure is 60 degree. When you bisected this angle, you got 30 degree each. Okay. From here, adding 60 plus 30, we get 1. Adding 60 and 30, we get 90 degrees. Okay. So, this is how we can construct 90 degree angle. Now, if you are asked to construct 30 degree, 30 degree, how to construct 30 degree? 30 degree lies between 0 less than 30 degree less than 60 degrees. Okay, 30 degree is equal distance from 0 degrees and 60 degrees. 0 plus 30 degree is 30 degree. 60 degree minus 30 degree is 30 degree. Okay. First thing, you need 60 degree angle. Consider line segment AB. Okay. Draw an arc with A as center. Now, keeping center here, cut another arc. Here we got 60 degree. Next step, keeping center here and center here, which means we are going to bisect 60 degree. When you bisect 60 degree, we get two equal 30 degree angles. Okay. For that, we need to bisect, keeping center here, cut an arc, keeping center here, cut another arc. We got an intersection of arcs. Okay. Join A and this intersection point. Angle formed here is 30 degree. Okay. So, we know how to construct 90 degree, 30 degree. Now, if it is 15 degree, how to construct 15 degree? 15 degree is, we have to bisect this 30 degree angle. Okay. Now, this center, take this point as center and this point as the second center, because here this is a point where the line cuts the first arc. From these 2 points, we'll be cutting 2 arcs and joining A and the point of intersection of arcs, we get 15 degrees. Clear? Now, if you are asked to find 75 degree, where does 75 degree lies? Between 90 degree and 60 degree. Okay. So, 60 degree here you have a point, 90 degree. Here you have a point where the line cuts the arc. Considering these 2 points as center, cut an arc here, cut an arc here. You will be getting a meeting point, join with A, you get angle 75 degree. What about 105 degrees? 105 degrees lies between 90 degree and 120 degree. Okay. So, you have to bisect the angle between 90 degree and 120 degree. Between 90 degree and 120 degree, you have a 30 degree. That 30 degree should be bisected. You will be getting 105 degree somewhere here. Okay, between 90 degree and 120 degree. Understood? This is our first topic, construction of tangent to a circle. We have 2 types. The first one is to construct a tangent to a given circle through a point on its circumference. A point lies on the circumference of circle. Okay. First, let us construct a circle. How to construct a circle? We have to take a center and some radius. Okay. Using compass and pencil, you all know how to construct a circle. So, this is my required circle. I am taking center as O. Now, consider any point on the circumference of the circle. Here, I will take a point P. The first step is, I am joining these 2 points O and P. What is OP? OP is the radius of the circle. Okay. We got the radius of circle. In the chapter circles, we have discussed that the angle between radius and tangent will always be equal to 90 degree. Okay, the angle between radius and tangent is 90 degree. So, in order to get the tangent, we need to make a 90 degree angle with OP. Okay, so you know how to make 90 degree angle we have discussed. First, we'll draw an arc with P as center. Okay, with the same measure, we'll cut an arc here with this point as center. So, you got 60 degree. Now, as this point as center, cut another arc. Okay, so we got 60 degree and this is 120 degree. Now, we have to draw the perpendicular bisector. We need to bisect the angle that lies between 60 degree and 120 degree. Okay, from this point as center, cut an arc. From this point as center, cut another arc. Okay, so these 2 arcs meet such a point. Clear? Now we got, when you join this point P and this intersection point, you get a straight line. This angle will be 90 degree. So, this line which we have drawn will be the required tangent. Clear? And P is a point which lies on the circumference of circle. Okay. Second one, to construct a tangent to a given circle from an exterior point. The point lies exterior to the circle. Okay. Here again, construct a circle first. We have taken some center O. With some radius, we are constructing a circle. So this is the required circle. Now, let us take this is the radius. Okay. Consider some exterior point. We'll take a point here. Okay. This is a point P. Now, in order to draw the tangents, what we have to do is, taking O and P as center, we are going to cut arcs. With O as center, that is, we need a perpendicular bisectors here. Okay. With O as center, with some measure, it is important that you have to take a measure which is greater than half of OP. When you join this line, you get OP. You know the measure of OP. Take a measure to draw the arc such that it is greater than half of OP. Okay. With some measure, you will be cutting an arc here with O as center and at the bottom also. Okay. With P as center, same step, cut arcs at the top and bottom. Now, join these 2 points where the arcs intersect. So, this is our third step. Okay. Here we got a point. What is the importance of this point? This point divides the line OP into 2 equal halves. This point is a midpoint because the line which we have drawn is a perpendicular bisector. Okay. You will be getting some point M, OM and PM are of equal measure. Now, OP. This OP we are taking as diameter of a new circle and we are going to construct a new circle. If OP is the diameter, then OM is half of OP. OM will be the radius. Keeping the compass here, M is taken as the center. We'll be drawing a new circle. Okay, OM is the radius. We are drawing a new circle. Okay, we got the circle. Now, here we got 2 points where both the circles intersect. When we constructed the new circle intersects the first circle at 2 points. Okay, from P, we'll be drawing a line to this point of intersection, also to this point of intersection. Okay, mark this point as A and B. Then AP and BP are required tangents. Understood how we have constructed the tangents to the circle with center O? We got AP and BP. We have studied that AP will always be equal to BP in the chapter circles. We have discussed this. Why? Because the length of tangent from an exterior point will be of equal measure. If you want to prove this, here when you consider these 2 triangles, triangle OAP and OBP, consider triangle OAP and triangle OBP. We'll be having OA equal to OB. What is the reason? OA and OB are the radius of circle. They will be equal. OP equal to OP. What is the reason? OP is common to both. And angle OAP will be equal to angle OBP. What is the reason? This angle will be 90 degree. The angle between radius and tangent will always be 90 degree. So, using the RHS criteria, these 2 triangles are congruent triangles. Then, using CPCT, we can say that AP will be equal to BP, corresponding parts of congruent triangles. Okay. Since the triangle OAP is congruent to triangle OBP. Okay. So, this is the proof. How? The length of tangents AP and BP we are getting equal. Clear? Next is the construction of a circumscribing circle of a triangle. First, let us take a triangle. So here we have a triangle. We are going to draw the circumscribing circle. For that, what you have to do is, this is my triangle ABC. For this triangle, consider any two sides and draw perpendicular bisectors of these sides. First, let us take AC. How to draw perpendicular bisectors? Take some measure in the compass, keeping A as center. Draw an arc here and at the bottom. C as center, arc here and at the bottom. Now, draw a straight line through these 2 points. So, you get a point here. This point bisects the side AC, or this line bisects AC into 2 equal halves. Clear? Okay, so we got a perpendicular bisector of AC. Similarly, we will draw the perpendicular bisector of BC. Keeping B as center, taking some measure in the compass, draw an arc here and here. With the same measure, keeping C as center, draw 2 other arcs at the top and bottom. Now join these 2. Okay. So this is a perpendicular bisector of BC. So we got the perpendicular bisector of AC and perpendicular bisector of BC. These 2 perpendicular bisectors intersect at a point. Okay, we can see a point here where they intersect. Now if you draw the perpendicular bisector of AB, again we will be getting a perpendicular bisector which passes through this point where the perpendicular bisectors of AC and BC intersects. Okay, so this point is the center of the circumscribing circle. Now what is a circumscribing circle? A circle which touches all the vertices of the triangle is a circumscribing circle. And this point is the circumcenter. Now, in order to construct this circumscribing circle, we can take OA, OB or OC as a radius. We have center at O. Taking OA, OB or OC as radius, we just need to construct a circle and the circle will be the circumscribing circle. I'm taking OA as the radius. I'll draw a circle with center O. So here I have a circle and this is the circumscribed circle. Okay, O is the circumcenter. And this triangle lies inside the circle. Okay, understood? Next is the construction of an inscribed circle of a triangle. Inscribed circle is a circle which lies inside this triangle. Okay, here we have taken a triangle. To draw inscribed circle, this is my triangle ABC. Okay, I'll be taking the angle bisectors. Here, let us take B and C angles. We'll draw 2 angle bisectors. They will meet at a point. This point will be the center of the inscribed circle. Okay, how to draw angle bisectors? When you take this angle B, to draw angle bisector, first draw an arc. Okay, so that arc touches both these sides. It touches AB and BC. From these points as center, draw 2 other arcs. With this point as center, cut an arc. With this point as center, cut another arc. Okay. From this point, draw a line to B. Okay. So this line, when you have to extend. Now this line you have to extend. Okay. Here we have bisected this angle B. Okay. This line has bisected the total angle B. Okay. This measure will be half of B and this measure will be half of B. Similarly, for C, we are going to draw angle bisector. With C as center, we'll draw an arc. Okay. Now, this arc meets the sides BC and AC at 2 points. Now, at this points, keep the compass, draw arcs. From this point as center, I'll draw an arc here. With this as center, with the same measure, draw another arc. Okay. Now, join C and this point, draw a line. So, we got a point where bisectors. So, we got a point where the angle bisectors of B and C meets. Now when you draw angle bisector of A, it also meets at this point. This point is the center of the inscribed circle and this center is called incenter. Okay. Now with this incenter, we are going to draw the circle, inscribed circle. For that, we have to draw the perpendicular from O to AB. How to draw perpendicular? Perpendicular angle will be 90 degrees. Okay, we need 90 degrees. How to construct 90 degree here? Now, with O as center, we'll draw a big arc, okay, to this line AB. Okay. Now, here the total angle will be 180 degree. Half of 180 degree, we get 90 degree. This point as center and this point as center, draw two other arcs. Okay. This point of center, you got an arc here. This point as center, cut another arc here. When you join this line, you will get the perpendicular bisector. Okay. Then this line makes 90 degree with AB. So, O, I'll mark this point as P. OP is a perpendicular drawn from point O to side AB. Now, OP will be taken as the radius of circle. We'll be drawing a circle with center O and OP as radius. Okay. So, this is the inscribed circle. Okay. We can see that the circle touches the triangle at 3 points. Okay. The circle touches the triangle at 3 points and the circle lies inside the triangle. So, it is called inscribed circle. And the center O is called the incenter. Okay. Next is the construction of a circumscribing circle of a given regular hexagon. Okay. What is a regular hexagon? Hexagon we know is a figure, is a polygon with 6 sides. And regular hexagon is when all the sides are of equal measure. Here, I have taken a line segment AB. This is a side of the regular hexagon. In a regular hexagon, all the angles will be of equal measure and that is 120 degrees. You know how to construct 120 degrees? With A as center, draw an arc. Here, with the same measure, keeping center here, center of the compass here, cut an arc. We got 60 degree. To get 120 degree, with the same measure, cut another arc. Here we got 120 degree. Okay. Now draw a line from A through this point. Next step, take this measure which we have taken for AB. We know that all the sides are of equal measure. With AB and A as center, cut an arc here. This measure will be equal to the measure of AB. I'll be marking C here. Okay. Now, from here again, measure 120 degrees. For that, take C as center, draw an arc. Okay. Now, with the same measure, cut an arc here. You got 60 degree. Keeping center here, cut another arc. You got 120 degree. Okay. Draw a line that passes through this point and starting from C. Next step, take the same measure AB. Here, keep the compass here and the pencil here. Take the measure AB. Keep the center as C and cut an arc. Okay. Here you got a point. This is point D. Now this measure, we got the side CD. Clear? Again, same procedure. Now, keeping B as center, we'll make an angle 120 degree here. So this is an arc. With the same measure, keeping center here, cut an arc, you got 60 degree. Cut the second arc, you get 120 degree. From B, draw a line through this point. Now, keeping B as center, take this measure and cut an arc. Okay, here you got a point. This measure will be equal to the measure of AB. So this is our next point. Let us keep it as some F. Okay, now with F as center, draw an arc. With the same measure, keeping center here 60 degree, keeping center here 120 degree. Draw a straight line that passes through this point of intersection and F. Now measure AB, keeping the compass here, cut an arc so that this length will be equal to the length of AB. Okay, this point is E. Now, when you join these two, and if you need, you can measure this. This also will be equal to 120 degree. So, this is the required regular hexagon. We have constructed regular hexagon. Okay. Remember, in a regular hexagon, the angle is 120 degrees. So, you have to measure 120 degrees each time you get a new side. Okay. Now, how to draw the circumscribing circle? Circumscribing circle should touch all the vertices of this regular hexagon. Okay. Same steps that we have followed in case of triangle. Consider any two sides. Let us take AB and PF. Okay. Consider any two sides and draw the perpendicular bisectors for these sides. For AB, to draw perpendicular bisector, keep the compass here at point A as center, cut an arc here and an arc here. With B as center, an arc here and an arc here. Now join this line. This is a perpendicular bisector. Now for BF, to get the perpendicular bisector for BF, with B as center and the same measure, cut an arc here. With F as center, cut an arc here. With B as center at the bottom, the same measure is taken, cut an arc here. With F as center, cut an arc here. Okay. Join this line. We got the perpendicular bisector. And this perpendicular bisector also, when extended, these two perpendicular bisectors of AB and BF meets at a point. Now, when you draw perpendicular bisectors of EF, DE, CD, CA, etc., all of these meets at this center point. Okay, and this point is taken as O, which is the center of the circumscribing circle. Now take OA, OB, OF, OE, OD or OC as radius and center O. Draw a simple circle. Okay, I'm taking OA as the radius, drawing the circle. So this is the circumscribed circle. Okay, the circle touches the vertices A, C, D, E, F and B. We got the circumscribed circle of the regular hexagon. Understood this? You know how to construct the regular hexagon? You need to remember this. All the angles will be 120 degree. With respect to each side, we will be taking 120 degree in order to construct a regular hexagon. Okay. Next is the construction of an inscribing circle of a given regular hexagon. So, we studied the construction of a circumscribing circle of a regular hexagon. Now, inscribing circle. You know how to construct a regular hexagon. Okay. So, let us consider a regular hexagon. This is a regular hexagon. In order to get the inscribing circle, what you have to do is the same steps that we have used in case of triangles to draw inscribing circle of a triangle. This is my regular hexagon A, B, C, D, E, F. Okay. Consider any two angles in this case. We will be drawing bisectors of these angles. Okay. When you take angle A, to draw the bisector, first make an arc with some measure and A as center. Now from this point as center, draw two arcs, one here and this point as the center, draw another arc. Okay. Join these. From A, draw a line which passes through this point of intersection of the arcs. Similarly, now for bisecting B, draw an arc. The arc touches AB and BC at 2 points. From this point as center, draw an arc with some measure, and this point as center, draw an arc. Okay, the measure should be same. Now joining this to B, here we can see that this point is where the bisectors of angle A and B meets. Now when you draw a bisector of angle C or of D, of angle E, angle F, everything bisects, these bisectors meets at this point, and this point is the incenter or the center of the inscribed circle. Now we'll draw the inscribed circle. For that, what you need to do is draw a perpendicular. You know how to draw a perpendicular? We have studied. Now let us take a perpendicular OP. OP is the perpendicular. To get the perpendicular, draw a complete arc to this side AB and then bisect it. Okay, bisecting, you will be getting the perpendicular bisector. The perpendicular bisector meets at point P for the side AB. Here, taking OP as the radius, you are going to construct a circle. Okay, OP as radius. When you construct a circle, this is the required circle. OP is radius and O is the center, and the circle which we got is the inscribed circle. Clear? Understood? Same steps that we have done in case of triangle. Here again, you are taking two angles. You can take any angle. Here I have taken A and B. BC is possible. CD. Any angles. Draw the bisectors of angles. They meet at a point. Take the point as center and draw a perpendicular to any side. It can be to AB, BC, CD, EF, any sides. Draw the perpendicular. This perpendicular is taken as the radius and O is taken as the center. Draw a complete circle, and this circle will be the inscribed circle. Okay. Let us now solve questions from exercise 19. Here we have the first question. Draw a circle of radius 3 cm. Mark a point P at a distance of 5 cm from the center of the circle drawn. Draw two tangents PA and PB to the given circle and measure the length of each tangent. We know to draw a circle. How to draw a circle? We need a circle of radius 3 cm. First, take your ruler and the compass. Put the pencil inside the compass and measure 3 cm. You know to measure 3 cm? Okay. Now considering a center O, will draw 3 cm circle. So this is my circle of radius 3 cm. Now we have to mark a point P at a distance of 5 cm from the center of the circle drawn. Okay, at 5 cm distance. Here we have 3 cm. This is my 5 cm distance. I am marking a point P. Okay. Now draw two tangents PA and PB to the given circle and measure the length of each tangent. What is a tangent? Tangent is a line which touches the circle at only one point. We need to draw two tangents PA and PB such that it touches the given circle. Okay. Now how to draw tangent? Let's see. We have studied the steps to draw tangents. You remember? Okay. Now what you have to do is you have to find the perpendicular bisector of line OP. I am joining this. Here we have line OP of length 5 cm. I am going to draw perpendicular bisectors. What are perpendicular bisector? In order to draw perpendicular bisector, we have to take a measurement which is greater than half of this distance OP. What is half of OP? OP is equal to 5 cm. That is, we have to measure in compass 2.5 and above. Okay. A distance that is 2.5 and above. What happens if you measure 2.5? You won't be getting intersecting point. Okay. So, you have to measure 2.5 and above. Any distance which is greater than 2.5 is possible. So, when you take 2.5 and above and measure and draw perpendicular bisector. For example, these are my perpendicular bisectors. Okay. So, we draw have drawn two arcs. From keeping the compass at O, we have drawn this arc. At P, we have drawn this arc. Similarly, at the bottom from O, with the same measurement, we have drawn this arc, and with P, keeping the center, we have drawn this arc. Now, next step, we have to draw a line passing through these two intersecting points. Okay, so this line is my perpendicular bisector. Okay, which means the distance O to this point and P to this point will be equal. So, I have got my perpendicular bisector. Next step is, let us mark this point as some M. Okay. Next step what we have to do is, taking this OM as radius and M as center, we are going to draw another circle. That is, we should take M as center and OM as radius. OM and PM will be equal. So, we are going to draw another circle. So, this is my new circle. Okay. Here, remember, you have to place the compass at M. Because M is the center, we are constructing another new circle. Okay. Now, you can see that the new circle touches at 2 points the original circle. Yes. Here, this is one point and this is a second point. We'll mark the first point as A and the second point as B. Now, from P, we are drawing a line to A. Okay. Similarly, from P, we are drawing a line to point B. Okay. Now, this PA and PB are the required tangents. We can see that PA and PB touches the circle at only a single point. So, these are the required tangents. Remember the steps. Okay. Now, what else? We have to find the length of each tangent. We have to measure the length of each tangent. Let's see. We have, I'm going to join this AO and OB. Okay. What is the measure of AO? AO will be equal to 3 centimeter. What is the reason? AO is the radius of circle. Similarly, BO will also be equal to 3 centimeters. Okay. Now, here we have 3 centimeter. Now, what is OP? OP is 5 centimeter. When you consider this triangle, consider triangle OAP. Okay. In triangle OAP triangle belongs to this bigger circle. Yes. So, this OP is diameter. We have studied in the previous chapters that when you have a diameter, the diameter subtends 90-degree angle on the circumference of circle. Or we know that the angle in a semicircle is 90 degree, which means this angle OAP will be equal to 90 degrees. Okay, which means this OAP is a right triangle. OAP is a right triangle. We have a side that is opposite to 90 degree. The side will be hypotenuse. Okay. And this will be the base and this is the height. Okay. We have OA square plus AP square is equal to OP square. For a right triangle, we are applying the Pythagoras theorem. Base square plus height square or altitude square is equal to hypotenuse square. Now put the values. We need to find AP. AP is the length of tangent. Okay. AP square will be equal to OP square minus OA square. AP square is equal to OP square. OP square is 5 square minus OA square. OA square is 3 square. 5 square 25 minus 3 square 9. AP square is equal to 25 minus 9. AP square is equal to 25 minus 9 16. Then AP will be equal to 4 centimeters. That is root of 16, which is 4 centimeter. We got AP 4 centimeter. Length of tangent AP is equal to 4 centimeter. What about BP? Here again we have 3 centimeter base and The hypotenuse is 5 centimeter, which means the altitude will also be equal to the root of square of hypotenuse square minus base square. Here we'll be getting 25 minus 9 again, and that is 16, which means AP will be equal to BP, and that is 4 centimeter. We get BP is equal to 4 centimeter. We have studied again that the length of tangents from a given exterior point will always be equal. Here again we are getting AP and BP equal. They are from a single exterior point P. Clear? Understood this? Next, problem number 2. We are doing question 4 of exercise 19. Draw a circle of radius 4.5 centimeter. Draw 2 tangents to this circle so that the angle between the tangents is 60 degree. Angle between tangents is 60 degree. First, let us draw a circle of radius 4.5 centimeter. I am measuring 4.5 centimeter with the ruler and compass. So, this is 4.5 centimeter. Let us take center O. With this 4.5 centimeter radius, we are putting a circle. So, this is the required circle. Okay. Now, we have to draw tangents. The given condition is that angle between the two tangents is 60 degree. Okay. Just consider this rough figure. If you have a circle like this is your center. Here you have a point. Okay. These are the radius. Now, from this point, we are drawing 2 tangents to the circle. Okay. Here, this angle is given, which is 60 degree. Okay. Now, what are these 2 angles? The angle between tangent and radius will be 90 degree. So, here we will get 90 degree and here also we will get 90 degree. Okay. Then, what is the measure of this angle? Angle formed at the center. What is the measure? Here, when you look at this, we will be finding that this is a quadrilateral. In a quadrilateral, we know that the total angle is equal to 360 degree. 90 plus 60, when subtracted from 360 degree, we will be getting 120 degree. Okay. So, the central angle will be 120 degree, or this is a cyclic quadrilateral. Okay. In a cyclic quadrilateral, we know that 360 degree is the sum of angles. Also, we know that opposite angles will be 180 degree. Sum of opposite angles will be 180 degree, or sum of opposite angles. They are supplementary angles. Here we have 60, which means this should be 120 degrees. Here we are going to get 120 degrees at the center. How to draw 120 degree angle? We know, right? First, we will draw an arc taking some measurement in the compass. So, this is the required arc. Okay. From this point, here we are keeping the compass at the center O and we have constructed this arc. Now, the compass needle should be placed here. From here, we will be drawing with the same measurement another arc. Here, we have taken this measurement. We will be drawing another arc with the same measurement. Now, what is this angle? This angle will be 60 degree. We need 120 degree. To get 120 degree, take the same measurement, keep the compass here and you will draw another arc. Okay. Now, this angle will be equal to 120 degrees. Okay. We got angle 120 degrees. Okay. Here, this point, this is a point where the radius touches the circle, and here we have another point where 160 degree angle. We have drawn a line from the center O touches the circle, which means our tangent will be touching the circle at these 2 points. Now, we know that the angle between the radius and tangent will be equal to 90 degree. We know to construct 90 degree, right? From here, taking this radius, keeping the compass here, we'll draw an arc in order to get 90 degree angle. So, this is my arc. How to get 90 degree? With the same measurement, first we'll take 60 degree, cut an arc. Again with the same measurement, we'll cut an arc. So, we got 60 degree here and 120 degree here. Now, we have to bisect these. Okay, then you will be getting from this part you will get a 30 degree. 30 degree plus this 60 degree gives us 90 degree. Okay, so we will be drawing arcs from this point and this point. So keeping the compass here, you get an arc here, and with the same measurement keeping compass here, you will get another arc here. Okay, so this is the line which makes 90 degree angle. Okay, similarly we will do here also. Here draw an arc with some measurement. With the same measurement 60 degree, 120 degree. We have put two arcs. Okay, from these points keeping compass here, you will get an arc here and another arc here. So this is my point of intersection of both these arcs. So joining this, I will be getting 90 degree angle. Okay, extend the line. So this angle is also 90 degree. So we got 120 degree, 90 degree, 90 degree, and then this measurement will be 60 degree. Okay, so let's put points A and B. Let this be a point P. AP and BP are required tangents. Okay, AP and BP are the required tangents. Clear? Next, let's move on to the third problem, question 5 of exercise 19. Using ruler and compass only, draw an equilateral triangle of side 4.5 cm and draw its circumscribed circle. Measure the radius of the circle. Okay. So first we have to construct an equilateral triangle of side 4.5 cm. What is an equilateral triangle? Equilateral triangle is a triangle whose all the sides are equal. Here all sides should be 4.5 cm. Also the angle measure, each angle measures 60 degree. All the angles are equal, all the sides are equal, and the measure of each angle will be 60 degrees. Okay, let's construct the equilateral triangle first. To construct the equilateral triangle, we have to first measure 4.5 centimeter and draw a line segment. Okay. So here we have line segment AB of length 4.5 centimeter. Now measure 4.5 centimeter using ruler and compass. Keep the compass here and cut an arc with this length 4.5 centimeter somewhere. Okay. So here I have cut an arc keeping the center A. Now similarly, keeping at B, we'll cut an arc with the same measurement, that is 4.5 centimeter. You will be getting here. Okay. So from this point, draw lines to A and B. I'll mark this point as C. Then the measurement of AC will be 4.5 because we have taken in the compass 4.5 centimeter distance. Okay, AC will be 4.5 and BC will also be 4.5. So this is our required triangle ABC. Okay, now we have to draw the circumscribed circle. What is circumscribed circle? A circle that comes exterior, outside the triangle. It touches all the vertices of the triangle is called a circumscribed circle. Okay, now let's construct the circumscribed circle. In order to construct the circumscribed circle, we have to draw the perpendicular bisectors for any two sides of the triangle. Okay, let us take BC and AC and draw the perpendicular bisectors. How to draw perpendicular bisectors? Take a measure. Here we will be having 4.5 centimeter distance. Okay. Half of 4.5 is 2.25. So we have to make a measurement which is greater than 2.25. If we take 2.25 or less, the lines cannot be drawn because the arcs will not intersect. So take a measure which is greater than 2.25, any measure. So measure some distance and draw arcs from point B and point C. Keeping at B, this is my arc, and keeping at C, this is my arc. Similarly, we need the perpendicular bisector. As we draw to the up, down also we have to draw. Okay. So these are my arcs. Now joining them. So this is my perpendicular bisector of side BC. Okay. Now we have to draw perpendicular bisector for AC. To draw perpendicular bisectors for AC, from point A, we have to cut an arc here and here. From C also we have to cut an arc here and here. Okay. They will meet at a point. Draw a line intersecting this intersecting point. Okay. Take this intersecting point. You can find an intersecting point of the perpendicular bisectors of sides BC and AC. Okay. This point is the circumcenter. Okay. Now let us mark this point is some O. This O is the circumcenter. With O as center, OA, OB or OC as radius, we are going to draw a circle, which will be our circumcircle. Clear? So here, this is my OA. OA as radius, I am going to draw a circle. So you are keeping the compass at point O and the pencil will be touching A. When you draw a circle, the circle touches the vertices A, C and B of the triangle. So this circle is the required circumscribed circle. Now we have to measure the radius of the circle. Here you can use ruler and compass. To measure radius, you just need to know the length OA. Okay, you can keep the compass here and the pencil here. Take the measurement and with this measurement, you can use the ruler to find what the radius is. You will be getting 2.6 centimeter. Radius will be equal to 2.6 centimeter. Okay. If you take OA, OB or OC, you will get the same measure, which is 2.6 centimeter. Clear? Next, problem number 4, question 9 of exercise 19. Using ruler and compass only, construct a triangle ABC in which BC is equal to 4 centimeter, angle ACB is equal to 45 degree and perpendicular from A on BC is 2.5 centimeter. Draw a circle circumscribing the triangle ABC. Okay, here we need a triangle. Let us take the base as BC, which is 4 centimeter. Then angle ACB is 45 degree. This angle should be 45 degree. Also, it is given that a perpendicular from A on BC. This is a perpendicular from A on BC is 2.5 centimeter in length. Okay. First, take the baseline. Using the ruler, measure 4 centimeter. Draw a line segment BC. BC of length 4 centimeter. So, we got the line segment. Next, we need 45 degree. How to get 45 degree? 45 is 90 divided by 2. First, we'll make an angle 90 degree and then bisect 90 degree to get 45 degree. How to make 90 degree? We'll draw an arc with some measurement, keeping compass at the point C. With the same measurement, placing the compass here, we cut an arc. You got 60 degree. We'll cut the second arc 120 degree. Between 60 degree and 120 degree, we have our 90 degree. For that, with some measurement, placing the compass here, cut an arc. Place it here, cut another arc. Okay. Here, when you draw a line from the point to the baseline BC, we get the perpendicular. Okay. We get the perpendicular. Now we need 45 degrees. To get 45 degree, we need to bisect the angle 90 degree. For that purpose, keep the compass here, cut an arc, keeping the compass at this point and this point. At this point, cut another arc. Okay. Now draw a line passing through this point to C. We get the angle 45 degrees. Okay. Now our point A, vertex A will be lying on this ray. Okay. It will be lying on this ray because this is at an angle of 45 degree from the baseline BC. Okay. Now how to find this A? What is given? We have a perpendicular from A on BC is 2.5 centimeter. This is also a point that is given in the question. Now, we'll be having A somewhere here. When you draw perpendicular from A, the measure will be 2.5 centimeter. To find A, what we have to do is consider this ray. Okay. On this ray, take a measure 2.5 centimeter. Keep the compass here. Measure 2.5 centimeter and cut an arc. Okay. Now, when I draw a line perpendicular to this ray, okay, I am drawing a line perpendicular to this ray. Okay, I will get a line which is parallel to BC. Yes. Okay, because this part is 90 degree. When I draw a line that is perpendicular to this line, it will be parallel to BC. Okay. Yes. Here, this line will be cutting this ray. If I draw a line perpendicular to this ray, it will be cutting this ray which has the point A. Then, the point where the new ray cuts this ray will give us the point A. Clear? For that, we need the perpendicular first. Now, to get the perpendicular, we'll make the angle 90 degree. Keeping the compass here, draw an arc. First, you need 60 degree. This is our arc. With the same measurement, cut one arc here. Keeping the compass here, cut the second arc. So, we got 60 degree and 120 degree. Now, bisect it. From this point, keeping compass here, draw an arc. From this point, keeping the compass, draw an arc. So, we got a point of intersection of the arcs. From this point, draw a line. Okay. So, here we will be getting 90 degree angle. Okay. Now, this line will be parallel to BC. And A will be lying on this line. Okay. So, somewhere here we will be having A. Because only you will be getting 90 degree perpendicular if A lies on this line. Clear? So, here we have a point where A is touching the line which we have drawn now. From this point to B, when you join, we'll be getting AB. Okay. So, this is the required triangle ABC. When you draw perpendicular from A to BC, it will be, here we will be getting 90 degree angle. Now, we have to draw a circle circumscribing the triangle ABC. Okay. To draw, what we need? We need the perpendicular bisectors. Here, first we will be bisecting BC. Keeping the compass here, cut an arc. Keeping the compass at C, cut an arc. With the same measurement at the bottom, keeping compass here, cut the arc. At C, cut the arc. Now join these 2 points. So, we got the bisector of AC. Similarly, we will bisect BC. For that, keeping compass at B, cut an arc at the top and at the bottom. Keeping compass at C, cut an arc at the top and the bottom. Now, join these 2 intersecting arcs. We'll be getting the perpendicular bisector. So, here we have a point where both the perpendicular bisectors of side AC and BC meets. So, this is our circumcenter O. Now, taking OA, OB or OC as the radius, we can draw the required circle. I am taking OB as the radius. So, this is my required circle. Understood? Clear? Problem number 5, exercise 19, question 13. Construct an equilateral triangle ABC with side 6 cm. Draw a circle circumscribing the triangle ABC. Okay. We have done a similar question. We need to construct an equilateral triangle whose side is 6 cm. 6 cm. We will take 6 cm AB. 6 centimeter. Just using the scale and a pencil, you will draw a line segment AB which is of length 6 centimeter. Now, take the compass and pencil, keeping A as center. We are going to draw an arc of measure 6 centimeter. We are going to construct the equilateral triangle. Taking this measurement, that is 6 centimeter, you are going to draw an arc. Okay. So, this arc is the first one, and keeping B as the center, keeping the compass here, we are going to draw the next arc which is also of the length 6 centimeter. So, this is my second arc. They will intersect at a point. Okay, both the arc will intersect at a point. From this point, join to A and B. I'll mark this point as some C. So, ABC is the required triangle. The length AC will be 6 centimeter. BC will also be 6 centimeter. So, we have the equilateral triangle ready. Now, we have to draw a circle circumscribing the triangle ABC. Okay, circumscribing, which means the circle will touch points A, B and C of the triangle. Okay, and the triangle will be inside the circle. Clear? How to draw? We'll consider any two sides and draw the perpendicular bisectors. At a point where perpendicular bisector meet, that point will be the circumcenter, which means the center of the circumscribing circle. Considering that point as center, we'll draw a circle with OA, OB or OC as the radius, where O is the circumcenter. Clear? So, here first take a measure which is greater than half of this distance. Here we have 6 centimeter. We have to take a measure which is greater than 3 centimeter. Half of 6 centimeter is 3 centimeter. So, you can take 4, 5, 6, anything. Okay. So, let us take some 4 centimeter. With this 4 centimeter measure, keep at B and draw an arc. Here. Okay. Similarly, keep at C. Center C. Draw arcs. This is the first arc. This is the second arc. With B, we'll be drawing another arc. This is the perpendicular bisector. Okay, so we'll be getting two portions which are equal. Similarly, now considering side AC, we'll be drawing arcs with the same measure. We have taken some 4 centimeter. This is my first arc. This is my second arc. From C, we'll draw 2 arcs. Okay, so joining them, we get the perpendicular bisector of AC. Now, the perpendicular bisector of AC and perpendicular bisector of BC meets at a point. This point will be taking as O. O is the center, which is a circumcenter. Now, with O as center and OA, OB or OC as the radius, we are going to draw circle. Okay, we are taking OA as some radius. The compass is placed at O and the pencil will be at A. We are going to draw the circle. So, here this is our required circle with center O and OA as the radius. Clear? We have first constructed the equilateral triangle of length 6 centimeter, after which we are drawing the perpendicular bisectors for any two sides. Then the perpendicular bisectors meet at a point which is the circumcenter, and from this center we are taking the radius OA and drawing a circle which is the required circumscribed circle. Understood? Next, problem number 6, question 17 of exercise 19. Construct a regular hexagon of side 4 centimeter. Construct a circle circumscribing the hexagon. What is a hexagon? Regular hexagon. Hexagon is a 6-sided polygon, and regular hexagon is a hexagon with all sides equal. Okay. First, we will construct a hexagon, a regular hexagon of side 4 centimeter. We know to construct an equilateral triangle. Okay. Similarly, we have studied how to construct a regular hexagon. Here, to construct a regular hexagon, first let us take a line segment AB of length 4 centimeter. We are drawing using our pencil and ruler a line segment AB of length 4 centimeter. Now, in a regular hexagon, we know that each angle will be equal to 120 degree. Okay. Here you have a regular hexagon. So this is my regular hexagon. A, B, C, D, E, F. In equilateral triangle, we know that each angle is equal to 60 degree. For a regular hexagon, each angle will be 120 degree. Okay. Now, we have to take 120 degree. How to get 120 degree? We know to make the angle 120 degree. First, we'll draw an arc with some measure. We'll draw an arc. Okay, this is my required arc. With this arc, keeping the center or the compass at this point and the same measure. Here we have taken some measure. With the same measure, we have to place a compass here and draw another arc, small arc, which cuts the big arc. So here we'll be getting 60 degree. Okay. Now place the compass here and draw another arc. Okay. Same measure you have to remember. You should not change the compass measure. The measure should be same. So we got another arc. So this line which I will be drawing from A to this arc, okay, makes an angle 120 degrees. Okay. Now we need 4 centimeter. So what you have to do is measure in the compass 4 centimeter and cut another arc. Okay. So this measure will be 4 centimeter. Clear? Now again we are going to take 120 degree from here. Okay. From here we need a 120 degree angle because we know that all the angles is equal to 120 degree. Here to get 120 degree, what I am doing is I am drawing another arc. Okay. With the same measure, keeping the compass, here we'll cut 2 arcs and first arc we get here. Now keeping the compass here, we cut the second arc. This points when joined, we get a straight line. Okay. Now here we have to get 4 centimeter again. To get 4 centimeter, measure in the compass 4 centimeter. Keep the center here and cut a point. Okay. So cut an arc, we get a point here. Okay. Now this is our 4th vertex. 1, 2, 3, 4. 4th vertex we are getting here. Okay. Similarly, we'll be taking 120 angle from B. Keeping B as center, draw an arc. With the same measure, cut the first arc. With the same measure, cut the second arc from this point. Here we'll be getting 120 degree. Okay. Now we need 4 centimeter. This is 4 centimeter. Keeping center here, cut an arc. So here this measure is 4 centimeter. Okay. Now from this point, this is one vertex. From this point, we need again 120 degree. To get 120 degree, keep the center here. Draw another arc. Okay. With the same measure, keeping center here, we'll cut one arc for 60 degree. From here, keeping center here, we cut another arc. This is 120 degree. Okay. Now draw a straight line. From this point, we'll be drawing a straight line. Okay. Now next step is measure 4 centimeter. Keeping center here, cut an arc at 4 centimeter. So we got the next vertex. Okay. This is 120, this is 120, this is 120, this is 120. Now we have 2 points here. Okay. When you join them, we'll be getting the regular hexagon. When you measure this, these angles will also be equal to 120 degrees. Clear? So we got the required hexagon, regular hexagon of side 4 centimeters. Now we need to construct a circumscribing circle. Okay. How to draw the circumscribing circle? We know to draw for a equilateral triangle. Here we are going to take the same steps. Consider any 2 sides. Okay. We'll name this A, B, C, D, E, F. I'm considering the sides AB and BC. Draw perpendicular bisectors. To draw for AB, here the length is 4 centimeter. We have to take a measure which is greater than 2 centimeter. Measure 2 centimeter and more like 3 centimeter measure you can take. Cut an arc here from A as the center. Now as B as the center, cut 2 other arcs. Top and bottom we are cutting 2 arcs. When you draw a straight line, this is a required perpendicular bisector. Straight line drawn from the 2 intersecting arcs. Okay, so this is my perpendicular bisector of AB. Now for BC we are going to draw the perpendicular bisector. As B as center, we will take the same measure, draw 2 arcs up and down. Okay, with C as center, draw 2 other arcs. Okay, now join these. So this is the perpendicular bisector of BC. Now these 2 perpendicular bisectors are meeting at a point. Take this point as the center of circle, center O. Okay. Now if you draw perpendicular bisectors for AF, EF, DE, CD, etc., we'll get this perpendicular bisector meeting at the same point O. So this is the circumcenter. Okay. Now we can take OA, OF, OE, OD, OC or OB as the radius and draw the required circle. Okay, I am taking OA as the radius. So this is my required circle. Okay, so the circle touches all the edges A, B, C, D, E and F. And the hexagon will be inside the circle. So this is my required circumscribed circle. Clear? Problem number 7, question 26 of exercise 19. Construct a triangle ABC in which AB is equal to 5 cm, BC is equal to 6.8 cm and median AD is equal to 4.4 cm. Draw in circle of this triangle. Okay. So, we'll draw a rough figure. Here I am taking BC as base. Now, A is the third vertex of the triangle. AD is the median. Okay. What is the measure of BC? BC is 6.8 centimeter. Okay. So, using the ruler and pencil, draw a line segment BC of measure 6.8 centimeter. Now, we have another side given which is AB. AB is equal to 5 centimeter. Before that, what is D? D is a point on BC such that D divides BC into 2 equal halves. Median is a line which divides the other side. That is, median starts from one vertex and the opposite side is divided in the equal ratio. Okay. Therefore, AD divides BC into BD and DC, where BD is equal to DC. Okay. So, D will be somewhere here and this is the midpoint. Clear? Now, we need AD. How to get AD? We know the measure of AD. AD is equal to 4.4 centimeter. Okay. Now, we have AB. First, let us draw an arc with this measure. Take 5 centimeter from point B, because we cannot take A because we don't know where A is. From point B, as center, we are going to measure 5 centimeter using the ruler. In the compass, keeping B as center, we will draw an arc of length 5 centimeter. So, this is the required arc. Okay. Then what we know is measure of AD is 4.4 centimeter. Okay. So, taking D as center and 4.4 centimeter is measured in your compass with the ruler. Okay. So, this two lines, that is the arc which is drawn with B as center and radius 5 centimeter and D as center and measure 4.4 centimeter will intersect at a point. They have a common because A is common to both. Okay. So, taking 4.4 centimeter, keeping D as center. This is D. D is taken as center and radius 4.4 centimeter. We are going to cut another arc. Okay. So, this is the arc. When you join here, we will be getting point A, joining A and B. Okay. This measure is 5 centimeter. Okay. Then join AC. This is the required median AD. Length of median is given, which is 4.4 centimeter. So, using these data, we have constructed a triangle ABC. Now, what we have to draw? We have to draw incircle of this triangle. How to draw incircle? For incircle, we have to bisect any two angles. For circumscribed circle, what we did? We have bisected the two sides of triangle. For incircle, the first step, we have to bisect any two angles. Here, let's consider the angles B and C. Let us bisect B first. For that, what we will do? We'll draw an arc with some measure. Take some measure. Keeping center at B, draw an arc. So, this is the arc. Okay. Now, this arc touches side BC and AB. From those points, this point and this point as center, we'll be drawing two other arcs. Okay. So, here keeping this as center, draw an arc with the same measure. Keeping this as center, draw another arc. Okay. So, this is a line which bisects the angle B. Angle B, if angle B is 60 degree, this part will be 30 and this part will be 30. So, the straight line bisects angle B. Similarly, for C, we are going to draw. Okay. Here we have C, point C is here. Now, construct, first draw an arc. So, this is the arc. Now, this arc touches points here and here. Okay. With this points as center, draw two other arcs. This arc and this arc. Okay. From here, this as center, we have drawn this arc. From this center, we have drawn the second arc. Now, draw a line to C from this point. Okay. So, the angle C is bisected. Here, these two bisectors of angle meets at a point. Now, this is the center, in center. We have got the in center. How to draw the circle now? To draw the circle, we have to draw a perpendicular to any of the sides from this center. Okay, from this center, we have to draw a perpendicular to any of sides. Let's take the side BC. We'll draw a perpendicular to BC from point O. Okay, how to draw a perpendicular now? Consider an arc to this side BC. Okay, from O as center, we'll be drawing an arc. Okay, this is arc. From these 2 points, now we'll be having the total angle 180 degree. From these 2 points, we are going to cut 2 other arcs. From this center, we'll draw one arc. From this center, we'll draw the second arc. Okay. Now, from O, we draw a line to this intersecting point of the arcs. This is the perpendicular bisector. Okay. We got the perpendicular bisector. This angle will be 90 degree. Okay. Now, let us take this point as some M. With OM as the radius and O as center, we are going to draw a circle, which is the incircle. Clear? We cannot take, as in case of the circumscribed circle, we cannot take OB, OA or OC as the radius. Why? Because they are of different measures. Clear? So, we are drawing a perpendicular, and with this perpendicular, we are taking a point M, which is on BC. Now, we'll draw a circle. So, this is the required circle. Okay. The circle we constructed is the incircle. Center O and OM as the radius. Clear? That's all for today. In today's class, we have discussed the construction of tangents, construction of the circumscribed and inscribed circle for a triangle and regular hexagon. We have solved many problems from exercise 19. Hope you all enjoyed this session. I'll be back in the next session. Until then, stay tuned to LearnoHub. LearnoHub free hai, par best hai. Thank you.